Hello, my name is Riley Rio.
And my name is Joey Lancia, and today we will be talking about plate tectonics.
Now, let's start with the basics. Where do plate tectonics occur in Earth's crust? Well, plate tectonics occur in the rigid outermost shell of the planet. These parts are the crust and upper mantle, or the lithosphere.
Now let's move on to Alfred Wegener. So who was Alfred Wegener? Alfred Wegener was a German polar researcher, geophysicist, and meteorologist. He found evidence to prove that the continents were once all connected in one giant continent called Pangaea. He also produced evidence that the continents are in motion, and he believed that this was because of the tidal influence of the moon.
Wegener had a lot of evidence to support his theory of continental drift. He used things such as the rock types, ancient climates, fossils, and the continental puzzle. The Mesosaurus and Glossopteris are great examples of evidence for the continental drift. The Mesosaurus was an aquatic reptile whose remains were found in eastern South America and southern Africa. However, it wasn't possible for it to have crossed the ocean between the two continents. This means that at some point they must have been connected and the Mesosaurus moved around in those areas. The Glossopteris was a fern found in all of the southern continents. This again means that at some point the continents were connected and the plant was spread across the land.
Rock types from adjacent areas of continents are another great example of evidence Wegener found. It was thought and proven that if the continents were once connected, then the rock samples from the adjacent areas of continents would be similar in age and type.
Wegener also used his skills as a meteorologist to find more evidence. He found that looking at the ancient climates, the previous formation of the continents is the reason for there being tropical areas in the northern hemisphere and icy areas near the equator. Wegener also found that the continents fit together, and this was called the continental puzzle.
There were two scientists that found more evidence to support Wegener's theory. They were Arthur Holmes and Harry Hess. They found a new mechanism for plate movement called mantle convection, or the pushing and pulling of plates. Their evidence for this was paleomagnetism, or magnetic polarization acquired by the minerals in a rock at the time that the rock was deposited or solidified. Another pair of scientists were Frederick Vine and Drummond Matthews. Vine was a PhD student under Matthews at Cambridge University. Their work looked at the patterns of magnetic stripes on the ocean floor. If Hess was right, they hypothesized the symmetrical pattern of stripes was no accident, but indicated that the Earth's magnetic field switches direction over time from its normal direction to the opposite.
It was later proven that mantle convection is the cause of seafloor spreading. Now, when talking about plate tectonics, you have to talk about plate boundaries and geological structures. So let's start with the multiple types of plate boundaries.
The first are divergent boundaries, which include oceanic ridges and rift valleys. Oceanic ridges are when the plates move apart, and rift valleys are deep faulted structures. There are also convergent plate boundaries. These consist of ocean to ocean to continent, and continent to continent. Ocean to ocean create volcanic island arcs, ocean to continent creates continental volcanic arcs, and continent to continent essentially create mountain ranges. Finally, there are transform plate boundaries. This is when plates grind past each other without destroying the lithosphere.
Folds and faults are two geological structures that occur because of plate tectonics. Folds are when the land's surface is pushed up to form hills or mountains. Faults are large cracks in the Earth's crust where rocks move against each other.
Well, that's the end of today's podcast. Thanks for tuning in. Hopefully we helped you learn something about plate tectonics. Tune in next time to learn all about climate change.